So in the previous video, we've seen that when you combine all these together, it becomes S sub n, and then you've got your remainder, remainder, remainder. Combine all these together, that will then give you your Rn. Well, your remainder would be less than or equal to this one individual value here, this one value here. So all these combined together will give you this thing here. Well, this thing here will be less than or equal to this one specific value here. So now let's put it to use. By the way, this thing here only works if you have an alternating series. So now let's put it to use. So let's say you're trying to sum this up to an accuracy of this. But how many terms do you need to sum up in order to get it to an accuracy of this? Okay, so in order to do that, we need to first make sure that it satisfies these three conditions. So remove your alternating component, remove this component, then what's left will be 1 over n factorial. So your un here, this is your un here. Make sure that they're all positive, and you can see that they're all positive. And then make sure that it's non-increasing. Well, n is getting bigger and bigger and bigger, so you've got 1 divided by something that keeps on getting bigger and bigger. So this has been satisfied. Make sure that the limit will be 0. So as n heads towards infinity, you can see that this thing here will head towards 0. So all three have been satisfied. So in order to use this, we need to make sure that all three have been satisfied. So now that all three have been satisfied, now let's put it to use. So we know this alternating series will generate something like this. So up to n, this is up to n here. So up to n here, this is our S sub n, and then the rest here will be our remainder. But then the remainder will be less than or equal to this one individual value here, to this one value here. So, well, yeah, so we've seen this in the previous video, but then we need we want the error to be less than this thing here, 0.00005. We want so this is our remainder. This here is our remainder. We want the remainder to be less than this value here. So now times both sides by this, that will then give us this. So now divide both sides by this, that will then give us this. So here, hang on, let me think. So let's tidy this up. Jump to a calculator. That will then give you this. So now we don't know how to solve this factorial thing. So now it's just a matter of guesswork. When n is 4, this thing here will be this. So is this greater than 2000? It's not. So this is no good. Let's try when n equals 5. When n equals 5, this thing here will be 720. Is 720 bigger than this? No, it's not. Let's increase n. So when n is 6, this thing here will be 5040. You see, this here is bigger than 2000. So n equals 6 is good. So what that means is S sub 6 would give us this. So now sum up everything. That will then give you this. So now what that means is, remember, our error is less than. We want the error to be less than 0. Blah blah blah. So if you look at this here, so this could be hang on, 0.000. Well, our area here is less than this value here. So let's say 4999999 here, because it's less than this value here. So now you can see you've got to. So this could be plus or minus. So you've got to round it. Well, either way, whichever way you round it off, it will take you to this value here. Okay.